Kia ora, Gabe, and the rest of you. Thought I'd just make a quick video. I'm actually on a call at the moment, but no one's there, so I thought I'd make a quick one. So the idea was that you're struggling with the taking your achieved answer to your mirrored answer. So I think I said in the post, let's try and make, like if I do 15 for example, write out f equals ex cubed, write out f dash, and that would be 3x squared times e to the 3x cubed. I think I might have said that wrong. 3x squared to the ex cubed. Write down g, which is 3x squared. Write down g dash, which is 6x. So when you write down the product rule, which is 1 divided by the other, it's the bottom one times the top one differentiated minus the top one times the bottom one differentiated, all divided by the bottom one squared. So if I go 3x squared times 3x squared times e to the x cubed minus f, which is e to the x cubed times derivative, that's 6x, all over g squared, which is 3x squared squared. Now, that's your achieved answer. To make it a little bit easier for yourself, you might maybe just expand the brackets and just simplify everything. So that'll be 9x to the power of 4 e to the x cubed minus 6x e to the x cubed, all divided by 9x to the power of 4. And now hopefully you can see that looks that looks a bit simpler than this initial one up here. But common factors, I've got a common factor on the top line of this e to the x cubed, so I'll take that out the front. I've also got a common factor of x, so I'll take that out the front, and I've got a common factor of 3, so I'm going to take that out the front, which leaves me with 3 times 3 is 9, x times x cubed is x to the power of 4, 3 times 2 is 6, and then x to the power of 4, so there's my answer. But I can actually simplify that even further, because now this is all times and divide, it's a rational expression, so I can cancel 3, make that a 3, cancel an x there, make it a 3 as well. So I've got e to the x cubed to 3x minus 2 all over 3x cubed. Okay, there's my answer. Now from there, that would be my answer that I could then use at a merit/excellence level. Getting that answer is not a merit or excellence skill. Getting this answer here is your achieved skill. This process to here is going to help you with merit excellence answers. Just looking at another question here, is there another question that we could do? That was a quotient one, so how about we look at a multiplicative one, product rule one. Let's have a look at 16, because that probably looks a little bit harder than the bottom ones. I'm not saying it is, but it looks a little bit harder. So again, 16. So f equals x squared minus 4x. So f dash equals 2x minus 4. G equals e to the x over 2. So, which is e to the half x. So g dash is half e to the half x. Product rule, multiply these two together, gives you write down the first, differentiate the second, plus write down the second, differentiate the first. So x minus 4 times a half e to the half x plus e to the half x times 2x minus 4. Again, let's write that out without the brackets, make it look nice. Change that to be x over 2 now. It's just 2x minus 4 e to the x over 2. Again, that is your, up here, that's your achieved answer. So we're just trying to make it a little bit easier. Common factors, well, there isn't many common factors apart from that there. So if I take that at the front, e to the x over 2 leaves me with half lot of x squared minus 4x plus 2x minus 4. But I could also expand that bracket. This would be e to the x over 2 into a half x squared minus 2x plus 2x minus 4. This is going to be e to the x over 2 into half x squared minus 4. Because those ones there will cancel. And now again, that's the product. That's another product that if I was to differentiate again, I could call that f and that g. And I could do a second derivative. Okay, and that's where you're going to use your merit or your excellent stuff. Okay, much easier to differentiate this again as a product there. Okay, hold on. Maybe one last one. We'll try 19. Okay, let's try another product one because that first product one was quite straightforward. So 19. Notice how I'm writing down f equals that. So f dash is 2x. G is e to the x squared. So g dash is 2x e to the x squared. And again, the product rule. So when I multiply two together, the derivative is I write down the first one, differentiate the second, plus write down the second, differentiate the first. I've got a really bad feeling that's wrong, but so I checked it. Seems right. So write down the first, x squared times the differential of the second, 2x e to the x squared, plus write down the first, e to the x squared, times the derivative of the first, which is that. So make it nice and pretty. So that's 2x cubed e to the x squared plus 2x e to the x squared. And then from there you can see common factors of this x e to the x squared. Other common factor of 2. There's another common factor in these x's. So the common factor is 2x e to the e to the x squared plus 1, because that is that. Alright, like that. Okay. Now, to do the product rule here, I've got actually a function times a function times a function. So I can't do the product rule there. So what I might do is I actually might leave it as e to the x squared bracket 2x cubed plus 2x. And now I've got a product rule that I can apply again. That's a fat pen. F and G that I could do to find a second derivative. But anyway, hopefully that makes sense, Gabe. It's a long video, but hopefully it makes sense.